can you tell me, so you already told diode, right? So diode means it's going to pass the current in one direction and it is going to block the flow in the other direction. Okay, so ideal diode. So now here we are going to talk about ideal diode. Okay, so ideal diode, it is going to act like a very perfect switch. Okay, so you already know, right, what a switch is going to do. So what a switch will do?
Yeah.
Switch, what will it do? On off, right? Like switch is generally
Yeah.
like on off. Now you see here, in diode actually it has two operating modes. Okay, so one is what this forward bias. Okay, forward bias is on state, right? Forward bias is on state.
Yeah.
And you have this so for the forward bias. Okay, so now this is the diode, so symbolically this is how represented. Okay, so this side is anode. Okay, this side is anode, this side is cathode. So current is flowing from anode to cathode, right? Anode to cathode. So now you see here, like when you take the internal construction, diode is formed by a p type and n type silicon coming in together. Okay, so when you take a p type silicon, n type silicon, when you bring it together, it's going to form a pn junction, right? So this pn junction is nothing but a diode. Okay, so this is diode. So here, first of all, you need to understand like what exactly is happening. Okay, so here it's going to operate on two mode. Okay, one is forward bias, that is on state, and the other one is what? Reverse bias. Okay, so other one is reverse bias. Actually reverse bias, it is nothing but it is off, right? Reverse bias means it is off. Okay, so do you know like the internal conditions? I mean, like, what will be the value of voltage, what will be current? Okay, so do you know it?
Mm, I've forgotten it. I
Okay.
think I'll remember if you tell me.
Okay, so no issues. Now maybe I'll write it here. Okay, so now in forward bias, okay, I'm writing it as FB. Okay, in forward bias, voltage across the diode, no, so this diode, it will be greater than zero, right? This is greater than zero. So forward bias means, what is forward bias? So you have your p type material, you have n type material. So if p type connected to positive terminal of battery, if n type connected to negative terminal of battery, okay, so then that is called what? Forward bias, right? So this condition is forward bias. Okay, so now in forward bias, voltage across this diode, it is greater than zero, right? Because we are giving positive voltage. Okay, so in that case, whenever current voltage is zero, current will also be greater than zero, right? Current will be
Yeah.
greater than zero. Okay, so now in this case, what is going to happen? So whenever voltage is greater than zero and current is greater than zero, so this diode will act like a short circuit. Okay, so in short circuit, what will happen? Current is going to flow continuously, right? Current is going to flow continuously and there will be no voltage drop. Okay, in forward bias, so you remember this one, there is no voltage drop. Okay, so voltage drop is 0 volts. Voltage drop is 0 volts. Okay, so you need to remember this condition. So voltage drop will be equal to 0 and current will be greater than 0. Okay, so in which case, whenever voltage across diode, so I am representing this as vd, whenever voltage across diode is greater than 0, current is going to flow freely. Okay, now we'll consider the second case, that is reverse bias. Okay, so reverse bias means, what is reverse bias? So in reverse bias, so you have p terminal, you have n terminal. So if n terminal is connected to positive terminal of the battery, if this p type material, if it's connected to n type of the battery, okay, so this condition is called reverse bias, right? So this condition is called reverse bias. So now in reverse bias, what is happening? Voltage will flow from where? Positive to negative, right? So this direction. Okay, so here voltage across the diode, it is less than zero. Voltage across diode is less than zero. Okay, so if voltage is less than zero, current will be equal to zero, right? So this will act like open circuit. Okay, so this is going to act like open circuit. Actually in open circuit, what happens? Current will be equal to zero, so that's why current is zero here. Did you understand? So in reverse bias, no current flow. In reverse bias, no current flows. But in forward bias, current is going to flow freely. Okay, so here current flows freely. Did you understand? Did you understand? So this is ideal diode. So this is how it is going to behave. I'm not sure if you are here. Are you here? Okay, okay, and then it's fine. So you understood, right? No, I can't hear you. I think so. Your mic is not working. You have to rejoin, maybe.
Hello, can you
Yeah,
hear
yeah,
me
yeah.
now?
And now it's fine. Now it's fine. Okay.
Yeah,
So
yeah,
now this is actually whatever we have discussed till now. So these are for an ideal diode. So for ideal diode, for forward bias, it's going to behave like an short circuit. Okay. In reverse bias, it's going to behave like open circuit. Okay. Open circuit means no current flow. In forward bias, short circuit, so current is going to flow freely. Okay. So that's the 2 points you have to remember. Okay, so now here just they have defined that diode. So diode is nothing but it has two terminals. Okay, so this is a non-linear circuit. So can you tell me why this is a non-linear circuit?
yeah. So it will not go directly linear with Ohm's law.
But in forward bias, like it's going right.
Yeah, not sure.
Okay, actually, linear devices mean its behavior should be same. I mean like when voltage what is that V is equal to IR, right? Okay, but in one case it behaves like I equal to 0 in reverse bias. Okay, but in the other case voltage drop is 0. Okay, so but voltage drop is 0 but current is greater than 0. Okay, so this is for reverse bias and this is forward bias, right? So this doesn't I mean like this is not in compliance with the what is that V is equal to R, Ohm's law. Okay, so that's why they are non-linear. Okay, current and voltage are not proportional. Current and voltage are not proportional, and if you try to draw this, what is that IV curve? No, generally for or on linear devices, you will get something like the straight line. Okay, IV curve, the curve between I and V, it will be a straight line. But here, like if you draw, it's not going to be a straight line. It's going to be something like it will be something like this. Okay, so that's why this is a non-linear. Okay, so ideal device is non-linear because its current voltage relationship it's not linear. Okay, and it does not follow Ohm's law, so that you remember. Okay, so generally this diode is going to operate like a check valve. It will allow current only in one direction. It's going to, when you apply voltage, it's going to allow current in only one direction. Okay, so this is implemented using a PN junction. Anode is the positive, cathode is the negative. So you remember this one. Okay, so this side is positive, this side is anode, so this side is cathode. Okay, so this is very important when you draw circuits and all. So can we go to the next?